Hello everyone. Today I'm going to talk about superimposed folding or interference pattern. Why super? Because superimposed folding are very important. Okay, and for understanding the superimposed folding, our visualization toward the third dimension is very important. Okay, we have to understand, visualize the 3D module. After that, these types of superimposed folding for understanding is very easy. Okay. Uh, how this summary is I have made. Okay, yeah, you need not to learn this summary. Okay, after that, you after watching the whole video now you will write yourself the whole summary. Okay, I just put uh, summary first for one reason. Okay, that here we have write a type of relationship, means type of superimposed folding. There are four type of folding. Okay, 0, 1, 2, 3. Okay, and planar non-cylindrical is one type, non-planar non-cylindrical is one type, non-planar cylindrical is type, planar cylindrical is the type. Okay, so how these planar non-cylindrical fold we can tell how domain basin is. Okay, I will explain all the things. Okay, and what is the relationship between the F1 fold and F2 fold. Okay, so uh, and this is how this is a shape for domain basin. This is the shape for the boomerang or mushroom shape pattern. This is the shape for the hook pattern. I'm not putting the shape for type 0 fold. Okay, okay, fold amplification. Why I will explain in the upcoming video. Okay, so up to this is the general thing. Okay, now I'm going into the superimposed folding. Okay, when an area is of more than two deformation phases, okay, second set of fold may superimposed on the earlier one. Okay, the modification or refolding is called as superimposed folding or interference pattern. Okay, this is type 0, type 1, type 2, type 3. Okay, uh, how these types are formed, what are the criteria. Okay, uh, some visualization I will show you. Okay, with that you will understand. Okay, in this, because before showing you the visualization, you have little bit concept. Okay, so that you can understand at that time. Okay, in type 0, force is applying only from one direction. Okay, in type 1, force is apply in this direction as well as from this direction. Okay, like this. Okay, and in this case, same way the forces are applying. Okay, but the condition is different. Okay, what kind of condition it is, I will tell you. Okay, and in this case, forces are applying from the same direction, like 1. Okay, and how it is different from 1 is from type 0, I will explain. Okay, this is the overall picture. Okay, now
It's type 0 fold. Okay, in type 0 fold, actual plane of F1 fold is vertical. This is the condition. Okay, actual plane of fold is vertical. Okay, and hinge line of the fold axis is horizontal. Okay, this is horizontal. Now if I apply the force from the same direction. Okay, now this is our F2. Okay, and this is our hinge line of F2. What is the relationship of hinge line or fold axis and axial plane with the F1? Okay, and what are the changes that are happened after F2? Because the forces are applied from the same direction. Okay, so as such, no changes in the axial plane of F1 due to F2, and hinge line is also not hinge line is also still horizontal. Okay, it is not curved or something. Okay, happened to it. So this type of folds are difficult to identify in the field if it is present. Okay, and it is very difficult to tell that either it is formed from a single deformation or it is formed from a two set of deformation. Okay, and we call it as the planar cylindrical fold because hinge line is still not curved due to folding, and axial plane is still vertical. It is also not curved. Okay, of F1. Okay, the planar cylindrical fold decided on the basis of F1 fold characteristics. Okay.
Now after watching the visualization, the force is applied from this side and this side, and we get the shape of this. This is our F1 fold. Okay, this is the axial plane of our fold, and this is the hinge line. Okay, and after applying the same force from the same side, we are getting this is our F2 fold. Okay, but what is the effect of F2 fold on an F1? Okay, there is no effect. Okay, everything is as it is F1. Okay, and in this F1 is parallel to F2 in case of axial plane as well as hinge line or fold axis. Okay,
Now type 1 fold. In type 1 fold, first condition is F1 fold is vertical. This is our F1 fold. Okay, suppose, and fold axis is also horizontal. Okay, now if I apply a force, from this side and this side. If I front from front and back. Okay, because axial plane of F1 and axial plane of F2 both are perpendicular to each other. If for perpendicular, we have to apply forces from the opposite, this way. Now if I look at this is our F2 fold. Okay, this is our F2 fold, this is our F1 fold. Okay, what is going to if I look at what is going to happen with the F1, it hinge line is now curved. If hinge line is curved, okay, we call it as a non-cylindrical. Okay, but axial plane is still not curved. Okay, so it is planar still, planar non-cylindrical. Okay, it is planar non-cylindrical decided on the basis of F1 fold. Okay, always remember that F1 generation. Okay, this is our type 1 fold, and which we call as dome and basin. Okay, if we look at this part, this is representing a dome, and in a similar way here we get a dome and dome. One dome is surrounded by 4 basin. Okay,
now after watching the visualization of type 1 fold, in this case in F1 fold, force is applying. In this way, this is the axial plane and this is the fold axis, okay. And if we apply, this is the F2 fold case, okay. This is axial plane on F2 fold and this is the hinge line of. Now, if we look at this part, okay, we are getting dome and basin shape pattern, okay. This is the 3D view of the pattern, okay. Suppose this is a dome, it is surrounded by 4 basin, okay. Okay. For more clarity, I have added one more slide, okay. Suppose this is the axial plane of, and this is the axial plane of F2 fold, okay. This is one for F1 and this one is for F2. Now, if we talk about the axial plane is still vertical, okay. Axial plane is still vertical; it is not curved. If axial plane is not curved, it means it is planar. Okay, but fold hinge line is curved, it means it is non-cylindrical. Okay, one basin is surrounded by 4 domes, or one dome is surrounded by 4 basin. Okay, and dips in case of basin dipping toward each other, and in case of dome dipping away from each other.
Now type 2 fold. In type 2 fold, condition is axial plane of F1 fold is inclined. Okay, inclined axial plane. Okay, in the previous case, it is vertical. Okay, now it is inclined. Okay, and now if I apply a force perpendicular to it, means from front and from back, what is going to happen to this? Okay, we are getting a feature like this. We are getting a feature like this. From this side we are looking like this, and from this side it is looking like this. Okay, if you modify this for you for better understanding, it is something like this. Okay, okay, now this is our F2 fold. Okay, and this line is our F1 fold. If we look carefully, our F1 fold hinge line is now curved. Okay, and axial plane is also curved, so it is non-planar, non-cylindrical fold, and it is forming mushroom shape or boomerang shape. Okay, how we will get boomerang or this kind of shape? If we now erode this part. Okay, we are getting a shape like a heart, something like that. Okay, suppose. Okay, this is our type 2 fold. Okay,
Now, after visualizing the type 2 interference. Okay, suppose this is the axial plane of inclined fold, and again I apply a force on it perpendicular to it. Okay, suppose this is like this. Okay, in this case we are applying a force like this. Okay, and we are getting a pattern like this. Okay, and if we erode this part, we are getting this shape. Okay, mushroom shape or heart shape. Okay, so we call it as a boomerang type or mushroom type. Okay, and in this case, now if we look at the axial plane, one axial plane is like this, no? Okay, but this one is our F1, this one is our F2. Okay, the F1 fold, okay, F1 fold axial plane is now curved. Okay, so it means it's not planar, it is non-planar. Okay, non-planar, and it is not cylindrical as well as. Okay, if we look at this part, hinge line of one fold is curved now, so it is non-planar, non-cylindrical. Hope you got. Okay, now this is the overall pattern, outcrop pattern. Okay, the same way uh, the basin and dome are seen in the Taiwan in a similar way. Okay, but the shape is different. Okay, these are the possibilities of type 2 fold. Okay, how the shape is vary. Okay, like mushroom. Okay, how mushroom. Okay, the angle it depend upon the angle between the fold axis and V2, and angle between the fold axial plane and A2. Okay, A2 is tectonic transport direction of second fold, and V2 is the fold axis of second fold. It means if you are able to visualize the third dimension that I shown in the in the visualization, you can understand after that these things. Okay, because it is not that easy. Okay,
Suppose this is our horizontal plane, horizontal layer, and this is our recumbent fold. In this case, axial plane is horizontal, and fold axis or hinge line is also horizontal. Okay, if I apply a force again, okay, we are getting a shape like this. Okay, this is our F2 fold, and this hinge is of F1 fold. Okay, this is the hinge line of F1 fold, this is the hinge line of F2 fold. Both are parallel to each other, and both are horizontal, and both are dipping in same direction. Okay, and in this case, hinge line of fold axis is not curved. Okay, hinge line is not curved. Okay, and but hinge line, if hinge line is not curved, it is cylindrical fold, and axial plane is curved, but so we call it as a non-planar cylindrical fold. Okay, this is our hook shape fold. Okay,
Uh, After watching the visualization, forces are applying like this. Due to that, the recumbent folds are developed. And again, the force is applying from the same direction, and we are getting the hook shape pattern. Okay, but if we look at this fold axis, one fold axis or hinge line, it is not curved. Okay, so it means it is cylindrical. But the axial plane traces, if we look at this, the axial plane is curved. So, so it means it is non-planar cylindrical fold. Okay, and it is type 3 pattern, and we call it as hook shape. Uh, this is the outcrop view of the. This is the outcrop view of the uh, interference pattern. Okay, hope you learned something from this video. And if you have any doubt or you need furthermore clarity on this video, just mention in the comment box. I will try to explain. Okay, try to share this video with your friends so that they can also get the benefit. Because in every exam we will get one question mostly related with the superimposed folding. Okay, Arctic Pi one. Okay, so these two